All right, good morning, everybody. Class has started. I'm so glad you guys are here. This is the week before the last week, right? So we're gonna have 3 review days. So just taking a look at what we got here. Oops, sorry, I moved that up. So just taking a look at what we got here. Today is the first of 3 review days. So that means we're going to be reviewing today. We're going to be reviewing Thursday. And then next Monday is going to be kind of our last hurrah before the test. So Monday is 3/8. So that means after our last review day, you're going to have from Tuesday to Thursday to get your final done. Friday is a non-school day. That's the day between trimesters. So just if you guys are really busy, maybe you work or you take care of family members, make sure you guys plan ahead at some point between Tuesday and Thursday to take and submit your final. It's not a very long test. It's just as long as a homework assignment, so it's not anything crazy. Remember, just like all of our homework assignments, it's open note, so you guys can use your notes. So it's really important today that as we're reviewing for the final exam today and Thursday, that you guys are taking notes so everything is organized. Now, lucky for you guys, the only thing that's going to be on the final is 6.3 and 6.4. Like, wow, just 2 sections. Okay, we spent a lot of time on those 2 sections. So what I'm going to do is today I'm going to practice with 6.3. So we're going to go over everything we did in 6.3. And then on Thursday, we're going to do everything we did in 6.4. And then on Monday, we'll just do a general review that mixes a little bit of everything together. Okay, so a nice little preparedness for that. So what you guys can do besides taking really good notes on this is make sure you guys have your missing assignments turned in. Okay, so remember there's no late penalty for missing assignments, so make sure you guys get those in. Also remember that if you guys turned in an assignment and you didn't get the grade that you want, all you have to do is email me the name of the assignment and say, hey, I want to redo this, and I can unsubmit it so that you can work on it and improve your grade. Okay, I have office hours every morning. So Monday, Tuesday, Thursday, Friday, I have office hours right before class. So all you got to do is join one of those, and I can help you with your homework. We can get some stuff done. Okay. With that said, does anybody have any questions about how these last 2 weeks, it's really less than 2 weeks, these last 2 weeks of class are going to go for this trimester, right? We're still going to be together for the 3rd trimester. Oh, one other thing to note, remember, right? If you did not pass first trimester, if you get, right, we're looking for a passing grade this semester with a C or higher can get you a passing grade for first semester. So remember that assignments are worth 80% of your grade. So if you turned in all of your assignments and you have unlimited attempts, so if we can turn in all our assignments, or you come in and work with me, get your assignments up to 100% and turn them all in, then you can easily get your grade back for first trimester. I can tell you guys right now, this deal will never be the same after this year. So next year, you're not going to have this deal. So make sure you guys take this up. Yeah, it's a really good way to get credit for Algebra 1 and move on to geometry. Okay. Does anybody have questions about that, or questions about what the final is going to look like, or how to get their grade back from first trimester? Any questions there? Okay. Well, just remember, guys, that we can. Yeah, and I appreciate you guys in chat. I appreciate you. Thank you so much for responding. But I'm here for you guys. So if you have any questions or concerns, please let me know. And let's do it sooner than later, right? Because the end of the trimester is a little too late. So I'm here to help. I want you guys to pass. We need to pass, right? That's our goal. So if you guys are sitting there and you're anxious, you're like, oh man, I want to pass, but I just don't know if I can do it. You can do it, and I'm here to help. You just reach out and we can do it, guys. But this is it. This is our final push. Okay. All right. So let's take some notes today. We're going to be focusing on 6.3, and we're going to just be like, hey, what did we talk about in 6.3, what do we need to be able to do? So 6.3 in our book was kind of like an intro to exponentials. Okay, so we're gonna do two things today. The first one that we're gonna do is linear versus exponential. Okay, so linear versus exponential. And one of the things that we really worked on is identifying, is something linear or is it exponential? And to do this, we did tables. So we're going to go ahead and make some tables. So let's do some examples. Oh, no, let's take some notes first. So linear means, right, so what's linear? Linear means that we add by the same amount each time. Okay, so we're adding by the same amount each time, right? So, and that amount, right, this is our amount. Okay, so we're just going to take, so again, we're just reviewing what we've already learned, right? So we spent a lot of time with linear functions. So this is where we add by the same amount each time. And the amount that we add by, right, we called that m, or our slope. Okay, so that's what linear is. And then this part, right, we were really big on exponentials. So what's an exponential? And please let me know if I'm going too fast. I might be going too fast right now. I'm a little worried by that. So again, linear is add by the same amount each time. Right, and this was our standard equation for our line, and the amount we add by was m, right? So we're adding the same amount. Okay, but exponential is different. Rather than adding, we multiply by the same amount. Okay, so the big difference here is this one is adding and this one is multiplying. Okay, so add versus multiply. And our standard equation, right, for exponentials is we had y equals a times b to the x, and this is the amount we multiply. Okay, so in this case, it's the b that we multiply, which is confusing, right? Because before b was our initial amount, right? And it's just like, come on, math people, let's figure this out so it's easier on us, right? Like, why does it have to be so confusing with switching? Well, the good news, guys, is for you guys for this year, you guys have your notes. So as long as you have this in your notes, you're going to be good to go. So the amount inside the parentheses, or the amount underneath the x, because sometimes there's not parentheses, that's the amount we multiply by, right? So it's the amount underneath the exponential, okay, is the amount that we're multiplying by. So here, do you see how it's what's in front of the x? And here it's what is underneath the x. Okay, so that is what we're doing in words. In practice, what we did is we looked at different graphs and we're saying, hey, is this a graph of a linear or exponential? And then, yeah. So let's do some visuals here. I'm going to add some visuals over to the side here. So I'm just going to make a little coordinate plane, a little Cartesian plane for linear. And I'm going to make a little Cartesian plane for exponential. So just so we remember what they look like, right? So a linear, right, is going to be straight. So it can look like that. And I'm just drawing a straight line from the bottom left to the upper right. Or, you know, it could be something that looks like this. Okay, so the lines look something like that. Okay, so these are just examples of linear lines. Okay, they're nothing, there's no equations. I just like we just have to remember a linear lines is something that's straight. It could even be horizontal. It could be vertical. So everything here is an example of what a line could look like. Now exponentials, right, are either going to look like this, okay, or they might look like this. Okay, so those are examples of exponentials. Okay, and you guys can have that in your notes in case you forget, so that way, right, we're not thrown off or shocked by that. And we're going to take a look at Desmos graphing calculator today, so that if you do forget, we can always just graph them, right, which is another benefit to this year, right? We have access to all this technology that we don't normally have, which is really nice. Okay. All right. So we have linear versus exponential, right? One, we add by the same amount, so it's a straight line. And when we multiply, so it's a curve like that. So what we're going to do now is, so this is how you tell the difference graphically. Well, what if you don't have a graph? What if we just have data points? So that's what we're going to practice next. Okay. So to do this, let's do an example. Okay. Is it linear or exponential? Okay. That's going to be the question. So to do this, we're going to create a couple of tables. So I'm going to have, here's our first table. We're going to have x on top, y on bottom. And I'm going to have on the top, I'm going to have 0, 1, 2, and 3. So on the top, I'm going to have 0, 1, 2, and 3. And on the bottom, I'm going to have 2, 4, 6, and 8. Okay, so that's my first one. And then my second table is going to be x on top, y on bottom. And it's going to be 0, 1, 2, 3. So on the top, it was 0, 1, 2, 3. And then on the bottom, I'm going to have 4, 8, 16, and 32. Okay, so what we're going to do is we're going to look at this data, right? So, and we're going to say, does this data, does it represent a linear or exponential function? Okay, and to do that, we're going to use our definitions that we just wrote down, right? So linear is when we're adding, and exponential is when we're multiplying. Okay, so to do this, what we're going to do is we're not going to look at the input, right? So up top here, this is our input. And then down here is our output. So we're going to be looking primarily at our output, right? So as our input changes, how is our output changing? Okay. So if we look at the top, right, notice how here I'm going +1, +1, +1. Okay. And then on the bottom, that's what we're going to try to figure out. Are we adding or are we multiplying? So for example, to get from 2 to 4, I could add 2 or I could multiply by 4. Well, let's just start by trying to add 2. So 2 plus 2 is 4. And then 4 plus 2 is 6. And 6 plus 2 is 8. Okay, so it looks like here I'm adding every 2. So if I were to look at, right, my slope, change in y over change in x, that is, I'm changing 2 over 1, which is 2. Okay, so notice how I'm changing 2, I'm adding by 2 for every 1 that I go up in my input. So this would be linear. Okay, and why is it linear? We're adding by 2 each time. Okay, so it's linear because we're adding by 2 each time. Okay, and this is going to be on your final, and this is why we're going over this. You're going to be given a table, and you're going to have to say, hey, is it linear or is it exponential? So the way to do that is to look at the output and say, hey, am I adding or multiplying? And again, if you guys have questions, feel free to use chat or turn on your mic. Okay. So let's move on to the next one. So again, input on the top, it looks like I'm adding by 1 each time. Okay. And then on the bottom, so now we can try doing addition. So for example, I know that 4 plus 4 equals 8, but here 8, this is plus 8, right? And this is plus 16. So that doesn't work. So it's not adding. So it's not adding the same amount. Okay, so if you look here, it says plus 4 plus 8 plus 16. It's not adding the same amount. Okay, so that's not our pattern. And I really appreciate the people sharing in chat. You guys are on top of this. Okay, so then I check multiplication. So 4 times what gives me 8? So I go 4 times 2 gives me 8. Well, let's see if it's the same thing. If I go 8 times 2, does that give me 16? It sure does. And 16 times 2 gives me 32. Okay? If you ever wonder how to get this, like if it's not easy numbers, what's the opposite of multiplication? The opposite of multiplication is division. So you could just say, hey, go backwards. 8 divided by 4 is 2. Or I can go 16 divided by 8 is 2. And 32 divided by 16 is 2. So again, this way, right? See how we're going to the right? If we go backwards, you just do the opposite operation. So if I'm going left, I would go 32 divided by 16, 16 divided by 8, 8 divided by 4, and then I get that 2, that constant 2. So yeah, you guys were right. So if I look, my delta y over my delta x is 2 over, sorry, I shouldn't do that. This is exponential. I got excited. So then this is going to be exponential. Because we're multiplying by 2 each time. Okay, so again, one's adding, one's multiplying. Okay, so does anybody have questions about this or concerns or anything? Because I'm going to have you guys try one of these on your own now in a second. Okay, so I didn't hear any questions, so I'm going to have you guys try one on your own. Okay, so this is a try on your own. Okay, so try on your own. So we're going to have 2 tables again. So here's table A, so let's do this. So I'm going to have x over y, and then I'm going to have 0, 1, 2, and 3. Okay, and then with the 0, 1, 2, and 3, I'm going to have 1, 3, 9, and 27. And then B, so I had 1, 3, 9, and 27 on the bottom. I'm going to have x over y again. I'm going to have 0, 1, 2, and 3. And then we're going to have 8, 4, 2, and 1. Okay, so I'm going to give you guys a little bit of time to do this. My pen just rolled away. Let's go ahead and give 2.5 minutes. But I know some people are still going to be writing this down, so get these problems down. And what you're looking for, right? Oops, maybe I should write that at the top. Is it linear or is it exponential? Okay, so we're looking for, is it linear or is it exponential? Okay, so I'm going to give you guys time to do that starting now. And if you guys have questions, you can type into chat or turn on your mic. All right, hopefully guys that was enough time to work on this. I'm gonna go ahead and go over this. So again here, taking a look, it looks like our all of our inputs are going up +1. So that makes it so we don't have to worry about that. If these weren't going up +1, then we'd have to worry about that, but no need to worry about that here. The y's, so again, I always like to start out with addition. So like for here, this is +2, but then here, this is +6. So right off, right, and then we're going here. So right off the bat, it's not adding. So I'm going to try multiplying. So what times 1 gives me 3? Well, that's going to be 3. And then 3 times 3 is 9. Ooh, this looks really good, times 3. So it looks like I'm multiplying every time. So I would say this is exponential, right? And why is it exponential? We're multiplying by 3 every time. Okay, so right, so it's important to note that we're just not guessing, right? We're just not, it's not a 50-50 guess. We know it's exponential because we're multiplying by 3 each time on the output. Okay, and I know a couple of people were talking to me in chat, so I know they got it. Is everyone else doing okay with this? Again, it's not a 50-50 like, hey, I'm just going to guess. We know because we look at the output, right? Either we're adding by the same amount each time or we're multiplying, because that's the difference between those two. Okay, so here, nice. Good. So here, it looks like, ooh, we're going down, aren't we? So if I was adding, I would add a negative number. So I might add -4. So if I add -4, I get 4. But if I add -4 here, I would get 0. So this is actually add -2, isn't it? And then this is add -1. So it looks like, you guys see how the numbers are changing? It's not adding. So this might be one of those where it's confusing, like what times 8 is going to give me 4. So I can work backwards. I can say, okay, 4 divided by 8. And I get 0.5, which is 1/2. So if I multiply by 1/2, I get 4. Well, if I go 4 times 1/2, I get 2. So this is times 1/2. And if I go 2 times 1/2, I get 1. So then I see here, oh my gosh, we are multiplying by the same number each time. This is exponential. Now, it's not in this section, but we did spend a lot of time on this. What kind of exponential is this? Is this growth or decay? Can you guys answer in chat? Is this growth or decay? Yeah, right? So, right, the number that I'm multiplying is less than 1, and I'm getting smaller, right? So this would be decay. And I multiply, right? What are we doing? We're multiply by 1/2 each time. Okay, and I get it if you guys are saying we divide by 2 each time, but remember, exponential is defined as what you multiply each time. So yes, we are in fact dividing by 2 each time, but we write that as multiplication, not division, because that's how exponents are written, right? It has to be y equals a times something, right, to the t, right? So it has to be 1/2 because we are multiplying, we aren't dividing. So cool. How are you guys feeling about this? Are you confident? Are you like, yeah, I remember doing this, I feel pretty good? What do you guys think? Where are we? Like, are we comfortable where we can move on, or do we want a little bit more practice? And guys, I want to hear from everyone. There's some people in here that I haven't heard from since the start of the school year in September. Okay, so from what I'm hearing is that I'm hearing people saying that I'm good, and then I'm hearing some people need a little bit more practice. So hey, let's do a few more. I'm totally down with that. Okay, so let's do a couple more. Okay, so let's call this C and D. Okay, so I'm gonna have another table here. Okay, so I'm gonna go this one I'm gonna go -1, 0, 1, and then 2. Okay, just a second. I'm going to come up with something, okay? So I'm going to go 45, 39, 27, 21, and then for D, I'm going to go X, Y, and I'm going to get -1, 0, 1, 2, and I'm going to have -2, -1, -1/2, and negative 1/4. Okay, so we're doing the same thing. Is it linear or exponential? And we're not just guessing, right? We're going to find out, right? If it is linear, how much are we adding by? And if it is exponential, how much are we multiplying by? So let's try these out. I'm going to give you guys the same amount of time we did before. So we're going to do 2 minutes and 30 seconds and give it a try. And if you guys are stuck or need help, please say something in chat or turn on your mic. Uh-oh, did I make a mistake? I don't think I did. I sure did. I sure did make a mistake, guys. Holy moly. This should be 33, and this should be 27. Thank you. I really appreciate you. Yep, I made a mistake. So there we go. So 45, 39, 33, 27. That's what happens when I'm just making up problems on the spot, right? Sometimes mistakes happen. There we go. And you know what? That you caught that, that means you're doing really well. Hey guys, do we need a little bit more time because of the mistake I made on the problem? Okay, I'm going to give you guys a little bit more time. Here, let's do an extra bonus minute. All right, guys, I'm going to go over this because we do have one other thing that we need to practice today. And I want to have a little bit of time to do that, but we're doing fine for time. Okay, so at the top here, I'm going to notice that my input is still going up +1 every time. So I'm not going to have to worry about that, which is really nice. Okay, and then on the bottom, okay, to get this, Now, when the numbers are bigger, it might be more difficult to see what we're doing. But I'm always going to try adding first, okay? Because to me, adding is really easy. So what I'm going to do is I'm going to work backwards. So if 45 plus some number equals 39, then I can go 39 minus 45, right? Going backwards. So it's minus 6. So I can add negative 6. And if you don't, if you're not sure about that, just go plus negative 6, and I get 39, okay? So this is kind of like a guess and check, right? So I looked at it and I say, okay, I think it's plus negative 6, and then I checked it, I got 39. So let's see if this pattern holds true. What if I go 39 minus 6? I get 33. Okay, and then what if I go 33 minus 6? I get 27. Okay, so if I look, it looks like I'm adding a negative 6 each time. So this would be linear, right? Because we are adding negative 6 each time. Wasn't a very good 6. There we go. Okay. So that's how I did that. Does anybody have questions about that? I thought maybe the bigger numbers might be a little bit more tricky and throw some people off, but it's the same idea. And if they're big numbers, you can always just use a calculator to help you out, whether it's the Desmos Scientific Calculator or it's a physical calculator. Okay, calculators are our friends. Okay, does anybody have questions about C? Yeah, what if I told you, now I don't want to be too crazy here, but negatives are just, I mean, right, they're actually, subtraction is just adding a negative. Right, just like division is multiplying by a fraction. So that's kind of crazy, right? It's actually not, I mean, we make it its own thing because it makes it easier to talk about, right? It's kind of awkward talking about adding a negative, right? Instead of just saying subtract 6 every time. But that's what you're doing. Adding a negative is the same as subtraction. Just like multiplying by a fraction is the same as division. So we use the words subtraction and division as like a shortcut. Crazy, right? Because everything could just be written in terms of multiplication and addition. And remember, multiplication is a shortcut for addition. Okay, so here, I'm going to try addition again. So negative 2 plus what gives me negative 1? Well, let's see here. If I go negative 1 minus negative 2, I get 1. So let's try that. Negative 2 plus 1 is negative 1. So I could try plus 1. But then if I go here, negative 1/2, oops, that's not 1/2. Negative 1/2 minus negative 1 is 1/2. So I'd be adding a half here. That's not the same, right? And then if I went negative 1/4 minus negative 1/2, I would get plus 1/4. So I'm not adding the same amount each time. So that's not going to work. So now let's try multiplication. Negative 2 times what gives me negative 1? Well, to do that, I can just work backwards. I can go negative 1 divided by negative 2. I get 1/2. So if I multiply by a half, I should get negative 1. So let's try that. Negative 2 times negative 1/2 equals, oh, I put in a negative here, didn't I? Well, what happens if we get rid of that negative? So if I just multiply it by positive 1/2, I get negative 1. So now is our next step. If I have negative 1 times 1/2, I get negative 1/2. So that worked. And if I take that negative 1/2 times 1/2, I get negative 1/4. Okay, so it looks here like I'm multiplying by the same thing every time. So this is exponential. And I know it's tempting to say divide by 2. But if I go write this again, it's going to be the 1/2 to the t. So I am multiplying by 1/2. So it's an exponential. We are multiplying. Oops. Multiply. I switched the lettering here.
multiplied by 1/2 each time. Okay, so there we go. We got that. Okay. All right. What we're going to do next is we're going to make sure we understand what these look like graphically. Okay, so we did a bunch of practice here. So we look like we have 10 minutes, and what we're going to do is how to graph exponentials.
Okay, so to do this, I'm going to open up Desmos graphing calculator. Okay, so I have Desmos graphing calculator open, and I'm going to type into chat. I'm just going to send this to everyone. Here's the link. It's just desmos.com / well, that's weird that it says calculator. It should be graphing calculator. And I think, I don't know how to switch. Anyways, let's go here. I'm going to go to projector mode. There we go. All right. So you guys can go ahead and make sure you're on this. And what we're going to do is we're just going to graph these and talk about them. Okay. So some ones that I want to graph.
Let's do this. So we're going to graph. Let's graph this one. So y equals 3 times 0.5 to the x. Okay, and I'm going to zoom in a little bit here so you guys can see that a little bit better. Okay, so to do that, I'm going to go to Desmos, and remember, we only type in the right side. Okay, because that's our input. So we're going to have 3 and then parentheses 0.5 parentheses, and then to get to the exponent, if you see down here in the bottom left corner, can you guys see down here in the bottom left corner? There's a keyboard. Does that show up on your guys' screen? Here. So down here, I'm just trying to make sure you guys can see this. Okay, good. So down here, there's a little keyboard, a keypad. If you click on that keypad, right, this shows up. And this little a to the b thing, that's our exponential. And notice up here how it went to up high, and then I'm going to type in x. And then boom, there's a graph of it. Okay, and then that's all you have to do to graph these guys. Okay, now just a little bit of things here. Remember, our domain is always going to be all real numbers. That means that our input, everything works. Okay. And then here, our range, and I'm just dropping this. This isn't as important. The range here is y is greater than 0. Okay. And I'm just name dropping this. It's not going to be terribly important, but it is important later on in your math career, so I thought I would do that. Okay.
Okay, and then let's go ahead. Does anybody have any issues graphing this or seeing this on Desmos graphing calculator? Right, and then it even shows you where it crosses the y-axis. And then I want you guys to try this one on your own. Here's f of x equals 3/2 times 0.25 to the x. So why don't you guys try that one on your own? Just go ahead and graph it. So if you guys are trying to figure out how to do the 3 halves, it's 3 divided by 2. So all you have to do is use the division symbol, because remember, a fraction is just division that someone chose not to do. So there, all I did was 3 divided by 2. And then I'm going to do parentheses 0.25. And then the shortcut for here is if you hit Shift 6, that also does an exponent. Okay. So just a couple of things I want to remember here, right? If there's a fraction, all it is division. So that's 3 divided by 2 out in front. Okay. Can you guys give me some feedback? Are you guys doing this okay? Is this working out? Are people able to graph? Are you guys, is Desmos graphing calculator working for you? Okay, it's important for me to know, because if you guys aren't able to use this, I need to know, because I'm counting on you to be able to use this not only for your review, but for your final as well. Okay.
All right, and then let's do our last one here. So our last one, and then we're going to talk for a second. Our last one here is going to be, let's say h of x is going to equal -2 times 7 to the x. I want you guys to graph that one. So graph this one, just to see the difference.
So you shouldn't be getting numbers. So you should be in the graphing calculator thing. So like this. So let me show you. You shouldn't be in the scientific calculator. So this is not the screen we want. This is just a calculator. So if we're doing, we want the graphing calculator. See how this is different? It's going to have a little window up here to the left, whereas the calculator is here. So we shouldn't be getting numbers. So again, I'm gonna post the link here. So I'm really glad you guys are giving me this feedback. Make sure you're on the graphing calculator. Okay. The scientific calculator doesn't have a graph. So it's going to, right? You're not, this is where you get values. You should be just getting a graph like this, and it's the desmos.com/calculator. Okay. Whereas the scientific calculator, that's where we plug things in to do algebra. This is like a normal calculator.
You should be able to do all of these, and if you want, you can do all 3 of them,
right? So if I go like this, transfer it here, this could be my first one. Okay, and then I could do the third one down here. Okay, so notice how you can graph all 3 of them, right? You can graph as many as you want. Now, the picture is going to get a little bit crazy, right? All you have to do is you hit the X here and it will remove that graph. Okay, so all I'm trying to make sure is that you guys are comfortable with using your keyboard. You're comfortable with using the keyboard that they give. Okay, I just want to make sure you guys can use this graphing calculator to do all of that. Okay, so with that said, I got to wrap up class. You guys have a review assignment, a 6.3 review assignment, and on it I put problems that are going to be just like the problems on the final. So that assignment is up. It is going to be due next Thursday. I've decided what I'm going to do is I'm going to make it worth bonus points. So if you complete this review assignment, I will make it worth bonus points in Skyward. Okay. So are people clear on that? I'm going to make it worth bonus points. So you're going to have 2 review assignments, and I'm going to make both of them worth bonus points. I think that what I'll probably do is I'll make them both total worth 1 assignment. Okay? So if you guys do the review for next class, yeah, right? So now that doesn't mean if you guys have missing assignments, get those done as well. I can't emphasize this enough, guys. We all want to pass. Okay, everyone should get the grade that they think they deserve, that they want. Okay, if you guys are not passing, make sure you're getting your missing assignments done. Make sure you come to you contact me so that I can help you. If you did not pass first trimester, you guys, if you get a C or better this trimester, you automatically pass first trimester. So if you did not pass first trimester, please, please, please get your grade up to higher than a C. Get it up to a B, get it up to an A, so that I can give you credit for first trimester.